So in this video, we'll be going over two words for our class. It's going to be called endothermic and exothermic. You've probably heard of these. You've definitely heard of in biology an endoskeleton and an exoskeleton. So the endo and exo really just means outside or inside, or in this case, we're going to use exit and enter. And the thermic part of it, if you think about it, if someone thermic, you see that word, a thermos, what does it do? Well, it keeps your drinks cold or it keeps your drinks hot. So it refers to energy, or like a thermal underwear or thermal pajamas. They're supposed to keep you warm, right? So exothermic really just means that heat, or in this case, energy, is being exo or exiting. So exothermic, exiting heat. Endothermic, the heat is entering or going into something. All right, and so we're just going to apply this using arrows to figure it out. So for example, a burning fire. So if you're next to a burning fire, which way do you think the heat or energy is going? Well, if you ever get too close, you feel the heat coming off the fire. So I'm just going to draw some arrows out, and this would be exothermic. All right, boiling water. Now, I don't mean water that was brought to a boil and then you turn the stove off. I mean water that you are trying to make boil. So if you think about it, you want to boil some water, you put it on a stove, and there's either an electric or a flame underneath, and so you're trying to make energy go into the water. So that is endothermic. Okay, now the water may feel like it's giving off heat. Like for example, if I pour a hot glass of water out into a cup, and I get my hands near it, I'll feel the heat coming off that hot glass, but that's not the boiling part. The water was already heated up, and now we're letting it sit out over time, and it's actually going to cool off. So when the water's just sitting there cooling down, then it's being exothermic, it's giving away heat. But if it's on the stove and I'm actively trying to warm it up, then it's actually absorbing heat. Glow stick, we can actually do the next two at the same time. Because if we think about it, fire gives off light and heat. Glow sticks give off light. You may not think they give off heat, but it's just so little that you barely notice it or you don't notice it. And the sun, same idea, gives off light. And light and heat are basically the same thing. So if you ever get these on a quiz, I would make sure that you include the sun, the glow stick, and the burning fire. They're all basically the same thing. They all give off light, they all give off heat, they're all exothermic. Okay, so that's pretty easy. Number 8, this is also an easy one. Photosynthesis does the opposite. Plants actually take in photons, which is heat, okay, or very similar to heat as far as we're concerned, and they use it to make chemical reactions and grow. So photosynthesis is an endothermic process. Now let's do the rest. Cold pack, making ice, and exercise. So for exercise, that's easy. If you go outside and you exercise, what do you feel? Well, you feel hot. Have you ever seen anyone exercising in the winter? You can even see at some points steam coming off of them because they're so hot that their sweat is literally vaporizing into steam. And so exercise is an exothermic process. Now these next two, I'm saving them, and you can even throw boiling water into this. If you know a heating cooling curve at this point, depending on the year and the way your periods line up, I may have taught you heating cooling curves first. I may have taught this first. Typically, this topic goes first, and then we apply it to a heating cooling curve, but I'm going to do it anyway. So on a heating cooling curve, you should know that here's your solid, your liquid, and your gas, and you know that this way is exo, and this way is endo. The saying we use to remember is when you exit a building, you go down the stairs. So if we think of these as stairs, the exit or the exo direction is always down the stairs, no matter what direction the stairs are in. And so we would say, all right, making ice. Well, what am I doing? I'm taking a solid and I'm taking a liquid and I'm trying to turn it into a solid. So making ice would be this. So if I'm going in the down direction, making ice is endo. Now a cold pack. Well, let's use not one of those chemical cold packs that you have to like shake or crack. Let's use the old-fashioned cold pack. What is it? It's a bunch of ice in a bag, right? So if it's ice in a bag, what happens to that ice when you put it on you? Well, it makes you feel cold, but the ice itself melts when it does that. So that is actually a solid turning into a liquid. It's this direction. So that is Endothermic. So a cold pack is endothermic because if this is the cold pack, it's actually going to be absorbing heat from your body and using it to melt the ice. And then boiling water would be a liquid turning into a gas, which would be in the up direction. So you can use, I always recommend to students to use this heating cooling curve as a sketch to figure out if phase changes are endo and exothermic, because some of them can throw you off a little bit. So just be aware of that. If depending on the year, sometimes you learn this first, sometimes you learn it second. It depends really on how your periods break down and labs and scheduling and all that. So if you didn't know this at the time, then you could just talk your way through it. And if you didn't know it, we're probably going to learn it in like a day, because these topics are usually taught either at the same time or within a day of each other, depending on the year. So that concludes this video on endo and exothermic.